We're at Ixia, and Charles, we're here to talk about 400 gigabit Ethernet. So to start with, let's define what we mean by 400 gigabit Ethernet. This is not 400 gigabits on one copper wire, right?
It's a complex implementation of a new technology of 56 gigabits per second SerDes. So it's behind that 400 gig port.
Okay, and 56 gigabits per second for a SerDes, that's a big deal, right? That's not old hat technology, and it's not easy.
We're now doubling the speed, just to make it simple. I mean, we're doubling the speed of the SerDes. And we don't have a manufacturing history of a large board form factor that a switch or a router requires. Now, very small devices have been built in the past, like optical transceivers that have very high bit rates. However, that's on a small little circuit board encapsulated in a metal box. Here we have essentially a microwave running on the circuit traces on a board. And it's a brand new set of challenges, not only for board materials, but for the laying down of the electrical circuits on the board itself.
Right.
And we've had to adopt things like forward error correction to correct for errors that inherently are built into these very high-speed serial lines.
Right, and that helps with some of the signal integrity, right? Because I mean, you made the joke about microwaves, but we've got so many lines going so fast and so densely packed.
On 400 gig E, because we are running at 56 gigabits per second SerDes, and there is PAM4 encoding, it has inherent errors. Because of that, we now have to have forward error correction as a mandatory.
Okay. When I first got introduced to forward error correction, it was in the 100 gig era, and it was described to me almost like a luxury item. You're saying that's going to be mandatory now for 400 gig. That's got to be pretty heavy duty forward error correction too.
With forward error correction, we're adding additional bits into the encapsulation process, essentially, and into the packet forming process, into the encoding and the decoding of data blocks that are used to transmit actual data on the wire. All of that extra work, which was modeled, 400 gig is modeled on the work done in 100 gig. So the good thing that happened there was they leveraged work done on the 100 gig E standard, but now they just sped everything up. It
still feels kind of early. I know you've been doing 400 gig already, but who's asking for it? Where's the demand coming from that makes it so urgent now?
An end user would be someone like a cloud service provider, or a Web 2.0 company with their networking infrastructure. Someone like a Facebook, or Google, or Microsoft, and IBM. Those type of companies, they're going to need these types of interfaces and these kinds of bandwidth improvements. Now, the applications that are driving them are part of what we would talk about are mega trends in the communication industry, right? The financial markets, they like to see faster transactions. 400 gig is faster than 100 gig. The line rate is a little faster. The line frequency is faster. Transactions can be handled. Data can be moved. So they save money in terms of a millisecond. So anything that the Ethernet community can do to deliver interfaces that provide higher bandwidth, that also meet the bandwidth demand curves that have been analyzed by IEEE teams, as well as the ad hoc bandwidth study that was done in 2010, believe it or not. That particular study demonstrated that multiple markets were growing at 50 to 95% CAGRs between 2010 and 2020, and having that kind of growth with multiple applications at the same time, and then having to also hit Moore's law growth curve for computing and I/O advancements to meet up with the bandwidth demands and the application demands, the need for 400 gig it's today.
From the web scale guys' perspective, I mean, they might be interested in a faster interface, sure, but it's not just about raw bandwidth and raw speed, right? They have other considerations going.
They're always looking for ways to lower the number of links, the actual physical ports that they're working with. And a higher bandwidth interfaces really does that. So if I had in the past 10 gigabit Ethernet links and I could replace those with one 100 gigabit link, I just got 9 links that I don't have to service anymore. 9 points of potential failure that I don't have to worry about. On 400 gig, it's the same principle. Only we'll be rapidly replacing just deployed 100 gig ports, if you will, in many cases, right, to 400 gig ports where it's applicable, both within a large data center environment and between campuses in data centers.
Okay.
Anytime the Ethernet community can produce a higher bandwidth interface that has a good cost per gigabit and can help reduce port counts, power consumption, and cost per gigabit, we're going to do it.
Okay, yeah. It's early for 400 gig. I'm curious, the interest and momentum you're seeing now, how does it compare to past generations?
I get the feel that with 400 gig, companies around the globe are really paying attention, one, because of the potential of the market for it, and second, because the bandwidth demand is definitely there.
Okay.
That's well documented.
Right.
And I think the third thing is people are recognizing the complexity of the technology and they want to get ahead of it now. The big bang for 400 gig is very likely to be later part of 2018, 2019, 2020.
This is all really amusing because I think back to 10 gig and how hard and how impossible it was going to be to put 10 gig on a wire, to have it actually go across a circuit board. Now we're talking about 400. It's insane. I don't bet against copper. Do you want to take a chance and say where you think the copper speed limit is going to be? When does this end?
Well, it doesn't. It doesn't seem to ever end. On 400 gig, there's no standard for a copper cable, yet the only thing today that we can use to connect, let's say, an Ixia 400 gig test port, QSFP-DD, for example, to another device, whether it's a development board with a chip on it or maybe an actual switch fabric, is a copper QSFP-DD. So when we ask the question, when will it ever end, how many people thought we could run 50 gigabit per second signals over copper conductors?
Right.
Right?
Yeah.
And how well could we do that when we were struggling just a few years ago, 3 years ago, to get 100 gig to run over copper conductors up to 5 meters? We're already at a couple of meters already with 400 gig and there's no standard. So does the market evolve as the requirements are known? Absolutely.
All right, well, Charles, thanks for your time.
Sure.
Okay.